Now that we looked at data cleaning and visualization, let's dive into some transformations. The machinery of Pandas helps you to perform analytics in an efficient manner. So we'll slice out some columns. Let's look at the first few rows of tag column in the table tags. So if you would remember, the head function is what we do to get that. We can just say tags, select the head column, and then head function. The next, we'll get the title and genres column in the movies table. So for that, we'll say movies, and then put our title and genres columns as a list inside that selection, and then get the first few rows of that using head. By default, it's going to give you the first 5 rows. Let's now think of slicing out or picking something from the middle of the ratings table. For this, I'll use rows 1000 through 1010. The notation for this would be get ratings from 1000 to 1010. We can easily extract the elements of a list this way from an index to an index. We could here actually just say get the rows until a certain number. Just like here, I can say until row 10 from the ratings. And here we see 0 through 9 with the indexes. Or I could just say from the end, give me 10 rows from the end. For that, I can say -10. And I'll get the bottom 10 rows of the same ratings table. Okay. You can also select a particular column by using its name. For example, tags tag, as you would remember. Here, we'll use the value counts function. Value counts function will let you find out the count of each unique value occurring in the input. In this case, the inputs to that will be what we typed here, tags tag. And then we'll count the values. If you would remember our Unix content, this is similar to the unique function in Unix. So we'll assign the value counts for all the tags using our unique function here is value counts into a series called tag counts, and then we'll get the first 10 elements of that. So let's run this. We'll see that sci-fi as a tag was the most, 3384 is the count for it, and it goes onwards like that. Negative indexes work here too, so if you want to make a copy of the same list in reverse, I can say what are the bottom 10 counts. They should be ones, bunch of ones, as you might guess. Oops. So let's run this. We'll see a bunch of ones because those only were mentioned once, for example. So what can we do with this? Now that we sliced out the top 10 and -10, last 10 values in the series, we can now leverage the inbuilt plot functions. I'm going to use the plot on tags for this. Let's look at this line. Notice how this line performs the slicing of rows. So we plot only the first 10 rows, and then we applied the plot function, and we create a bar chart out of that. So when we do that, we'll see the top 10 tags in our tags data frame. We can now also look at filtering out some rows. What was filtering? Filtering is a common functionality when you select data that matches a criteria, that matches your criteria. Think of it as 2 steps. First, we need to develop a filter that encodes our criteria. Then we need to, that filter will be applied as a mask to our data frame. So the filter criteria will label each row in our filter as true or false. As you might remember, we've done this before. here, what we'll do is we'll create a filter called is highly rated. What is highly rated? It's any movie with rating 4.0 or more. So we'll use a filter to select out rows with rating greater than or equal to 4.0. So here we do that. We assign actually is highly rated. The ratings, we'll select the rating column out of the ratings table, and then we check if that value is greater than or equal to 4.0. Then we'll just display here the bottom 5 rows in the ratings data frame to match this criteria. Okay, so let's run this. Is highly rated will have true-false values that will contain Boolean values, so to say. And the checking will be performed by, again, greater than or equal sign, if you notice that. And we applied that as a filter to the ratings table here, and just displayed the bottom 5 rows, or we could have done rows, let's say, 30 through 50. We could have seen other rows in that same output, and we sliced out the dynamic output of that filtered ratings data frame, and we displayed about 20 rows in there. You see that it just so happens in this slice all the ratings are 4.0, but they should have all been 4.0 or more. We'll do a very similar thing with is animation. What is animation? It's a movie with a genre of animation. So then we need to find in our movies data frame all movies with genres that has animation mentioned in them. So genres in the movies table, the column genres, will be a string value. We'll see in our filter if that string value contains animation. The way to do that is if we look at here, we select movies, the genres column from the movies, and then to what we get, we apply string contains function. It's a string function that we'll review also later. But what it does is it gives us true or false values based on the string it's applied to. So for each string value in each row in the genres column, this is going to check if that string contains animation. And this will generate a filter series called isAnimation. We'll take that with true or false values in it again. We'll take that and apply that filter to movies. And let's get rows 5 through 15. Let's run this. We see that there are some movies here. And each of them will have that animation somewhere in their genres column. So in order to get the rows which match our criteria, we simply index the data frame using a filter we created. For example, again, just to review, movies is animation will give us all the animation movies with animation mentioned in their genres. So now let's see a few aggregations. Aggregating values across rows gives us a big picture about the whole data set. So it's very useful. Pandas provides a function, as you would remember, called group by. We will use this function to perform aggregation on a data frame. So once we perform the group by, we'll see that we can use other functions such as count or mean to get the exact statistics we are looking for, or to do something else with this series object or data frame we get from group by function. For example, here in this first one, ratings count will give us the count of movies for each rating. So the rating for each movie. So here we select movie ID rating from the ratings data frame. We'll apply group by function and we'll group over rating and we'll count those. So when we have that, we could see that we have the movie ID and the rating for that. So next, let's look at average rating for each movie. So for that, which makes more sense than our first query in that sense, first grouping. For this, we'll group the movies or the ratings we select by movie IDs. So here, something to recognize is that the column we used for grouping by over, in this case movie ID, it will become an index for the data frame, which I said it makes more sense because it's an ideal index. It's the identifier for the movie rather than the rating of a movie. So once we have that, we can actually apply an average function for this, right? We'll call this an average rating because we are taking the mean of these groups by movie ID. So here then we can get the tail of it or the head of it. And let's also turn this into head. We can get the average rating for every movie in our ratings database. This is always a good thing to know, especially when you're selecting a movie. We can also count how many ratings are there in our database for each movie ID. We do the same query or same group by aggregation. We get ratings, movie ID, and rating from the columns that it has. And we are grouping things by movie ID. And then we are applying this count function to it. When we do that, we could see how many ratings per movie. We could also see the tail of it, as we've done before. And we see some movies have only one rating each. Okay, let's stop here and review some data frame merging operations next.